Hey guys, so today we're going to be processing down some gold that I collected, some really dirty stuff. So several little BBs in here. You might, and there's still some left in the beaker as well. They look pretty dirty. And that's why I'm going to go ahead and purify them again. Some of these you might remember, like those littler ones, just came from my last video. Processing gold from various PCBs, I believe. This larger one was from the video before that. That was, I believe, called Noble Metals from Electrolysis, or Copper Electrolysis. I expect there to be, I know there's a lot of copper impurities in this, and I expect there to be some silver in there as well. But I know for a fact that there's a decent amount of gold in here. So the first thing I'm going to go ahead and do to start this is I'm going to add some hydrochloric acid. Added about 100 milliliters. And there's not going to be a whole lot of reaction at first, but I'm going to go ahead and let this sit for a little bit, just to see if it pulls anything off the surface. Like I expect it to pull off some copper oxides. And in fact, it looks like it's turning a little green already from dissolving those copper oxides. So I'm going to let this sit for a little bit, and then here in a little bit I'm going to go ahead and add some hydrogen peroxide, and then I will go ahead and start shooting again then. Okay, so I've let this sit for maybe half an hour or so, and it did seem to clean them up a little bit. Let's see if I can show you. I'll use a flashlight. As you can see, a lot more actual gold metal right on top here. I was just primarily for curiosity to see what it looked like after the surface had been slightly eaten away. So what I'm going to go ahead and do is I've got about 60 milliliters of hydrogen peroxide. We're going to go ahead and add it to the solution, and this should remove any of the copper contaminants, except for maybe in that really large nugget. There may be some copper in the middle. But we'll see. We'll see how it goes. And this process can take a little while. So I'm not going to sit here and film the entire thing. But I will go ahead and come back once it's eaten a good chunk of it away. So this has been sitting for a while, and I think it's pretty much done reacting. As you can see, it did dissolve a fair amount of copper by the green color, but it doesn't seem to have dissolved as much as I thought it would, which I guess is both a good and a bad thing. So I'm going to go ahead and decant this, and then we are going to do an acid bleach bath to actually dissolve the gold. Let's see. It did appear to clean up a little bit there. I'm going to go ahead and spray this out. Okay. It doesn't look a whole lot better on some of them pieces, but we will see. So we have another 100 milliliters of hydrochloric acid. We're going to go ahead and pour it in here. And then we're going to go ahead and add a couple pipettes of bleach. And then we're just going to go ahead and let it do its thing. This also is going to take a little bit given how big the pieces are. I'm not going to go ahead and film this entire reaction. If you want to see the reaction of hydrochloric acid and bleach dissolving gold, you can see my last video, processing gold from PCBs, the one I had mentioned earlier. And there I actually go through and show the entire reaction of dissolving the gold flake, which is a much faster reaction than what this is going to be. But once this is done, we'll go ahead and pick it back up and see what we're left with. So it's a few days later, and this is finally done. Obviously, I had to add some more acid and bleach to it. You know, normally, whenever I process gold, I use hydrochloric acid and nitric acid. But I have run out of nitric acid, and one of these jugs costs over $200 to buy, and this shit's expensive. So that's one of the reasons why I was wanting to try the bleach approach. Now, while it seems to work really well for, you know, like gold leaf or stuff you would get from electronics raw, you know, as it just came off, it does not do good for anything substantial. At least it takes days and days and days. I had to put it on my stirrer here, and it still took days, you know, of stirring and slowly adding before everything was dissolved. Right now I'm letting it all settle out, and that got me motivated enough to start work on a electrostatic, I guess you could call it, a nitrogen generator, or a spark gap nitric acid generator. Essentially, I had seen this on another YouTube channel, Cody's Lab. If you haven't seen that channel at all, definitely go check it out. It's a pretty awesome channel. But on there, he had a spark gap going inside of a jar and was pumping air in and out of the jar and bubbling it through water. And as he explains, it rearranges the air molecules as it ionizes the air between that spark gap. And some of it turns into nitrogen dioxide, which you then bubble through water to make nitric acid. And I don't want to have to use acid and bleach on gold nuggets again. So I would like to have my own method of making nitric acid. So I'm going to give this a shot. So this video has turned into, you know, from processing gold to making nitric acid. I will be using this neon sign generator to ramp up the voltage. I've had this for years and just never even tested it. I just now tested it, making a crude Jacobs lighter just to see if it worked. I'll cut that video in as I tested it earlier today. But it works. It ramps it up to 9,000 volts, which is more than enough. I have some brake line I'm going to use, and this is a really thick piece of acrylic. It was a misprint from a sign shop, and they were going to throw a bunch of pieces like this away, so I grabbed them. I just couldn't think of what I would use it for, but this is going to work awesome. I will go ahead and have the brake line running in, create the spark gap on the inside, and that brake line will allow me to pump the air in and out. And I've got a little fish aquarium, or a fish tank aquarium pump, air pump, bubbler, that will pump the air in and out of here. But first I need to go ahead and get all the lines drawn out on this that I want and start routing it out with the Dremel. Okay, so now these are seated in here. And as you can tell, whenever the jar comes on or drops on, it sits below. That way I can seal it all up. And this acrylic should act, in theory, like an insulator and stop it from arcing between, before it gets inside the jar. Which it needs to be fairly close in order for it to start arcing. So that's what I'm going to try to do right now, is keep these in here and then bend them over to each other at the base, and then spread them out, kind of like a Jacob's ladder inside. Okay, so let's check and see if this works. Okay, looks like it's working to me. It looks awesome. Now let's check it with the jar on to make sure. If I don't break it first, let's check it with the jar on to make sure it's going to work. Okay, so everything is working out pretty well thus far. So what I'm going to use next is just rubber cement. I'm going to use this to seal up any air holes or anything like that, just to make sure everything is airtight. And what I'm going to do first is I'm going to go ahead and line the inside here, the bottoms of these gouges that I made, to make sure that no air comes out from underneath the brake line. So yep, this is what you get when you don't think before you start plugging things in. I wanted to test to make sure the spark gap worked before the glue dried so I could make any adjustments just in case I needed to. And I didn't even think that the vapor was like pretty hardcore flammable. So huge huge fail on my part. Okay, so I got it all sealed up, and pumping air through it right now, and it seems to be working. So we're going to try firing this up again and see if this actually works. Okay. So we're going to go ahead and let this run for a little bit, and it should fill up that bottle there with the red gas, the nitrogen dioxide. And then we'll test out the water and see if that is going to be nitric acid. Okay, so I was letting this run for a little while, and it was working fine. And then all of a sudden something happened right up here where I'm guessing it broke down the rubber cement that I used, and it's starting to spark in between here. I'll put it on and show you real quick. You see. Now, while that does produce the same effect, it's not in the manner that I want. So what I'm gonna have to do now is rip this thing apart, and I have some neoprene I'm gonna put in here. And then I'm going to use caulk, or I should say silicone, rather than rubber cement. And hopefully that will make a difference in whether or not this thing can seal and then not arc over. Okay, so I've got it essentially rebuilt. I use silicone instead of rubber cement. And then I got that neoprene stuck down in here as well. And hopefully that will be enough to keep it insulated. But I'm gonna go ahead and fire this up for the first time. As you can see, it's airtight, it's bubbling. Another thing I also did was I zip tied a piece of gauze to the end of the hose, in an attempt to disperse those bubbles a bit more. The more surface area for the gas to dissolve into the liquid, the faster it'll work. So let me go ahead and plug this in and we'll see if it works. Well, it looks like it is working and not arcing over. Okay. So far so good, but it took about 15 minutes or so for the rubber cement to fill. So I'm gonna stay up here and watch this, and we will see how this works. So I've been letting this run for probably a good 4 or 5 hours now, and I've got some little pieces of copper in the bottom of this glass. We're going to test it to see if we get any sort of reaction from what this is supposed to be nitric acid. I'm just going to pour a little bit in here, and if it is, we should start to see some bubbling. Okay, I wanted to get a bit more close-up view of it dissolving the copper. Yeah, I'll let this run for another 8 hours, and then should be hopefully good enough for me to start using.